Welcome, everyone, to the Foundry by Forge College. I am so incredibly excited to be your host today. Let's just jump right in, shall we? Go ahead and grab your virtual lab coats and maybe your magnifying glasses, because today we are doing a real data detective experiment right here in the heart of our advanced Solana concepts check. In our previous explainer, we talked all about designing network efficiency benchmarks for Gulfstream. Well, today it is time to actually build the machinery for collecting and analyzing those transaction flows. Okay, let's dive straight into this blueprint. Here's our step-by-step lab procedure for mastering Gulfstream transaction forwarding today. We are going to start with the network efficiency lab, then building your collection pipeline, validating the benchmark schema, aggregating the metrics, and finally, spotting anomalies and next steps. Section 1, the network efficiency lab, from blueprint to execution. So, as you know, we designed a pretty comprehensive benchmark blueprint. But here is the central detective mystery that we need to solve first. We designed it, sure, but how do we actually catch the data? I mean, the Solana network processes thousands of transactions every single second. How on earth do we safely grab this incredibly fast-moving data without getting completely overwhelmed or, missing the crucial details of Gulfstream's behavior? Well, the secret lies in something called an RPC endpoint. Think of an RPC, or remote procedure call node, kind of like setting up a motion-activated trail camera out in the forest. You aren't interacting with the wildlife at all. You're just quietly sitting there watching the transaction data scurry by. And for those of you who might be new to this, don't worry. Simply observing the network via these RPC queries is perfectly safe. We're literally just reading data here. We won't be signing anything or moving a single cent of funds in this experiment. Moving right along to Section 2, building your collection pipeline, equipping the data detective. Every good scientific experiment requires a clean, isolated workspace before you start mixing the chemicals, right? The exact same rule applies to data science. So here are the foundational steps to get our Python pipeline up and running. Step 1, we set up a virtual environment. This is absolutely crucial because it keeps our project entirely isolated from the rest of your computer. Step 2, install our dependencies. We really just need 3 simple tools for this: Solana for talking to the network, pandas for handling our data tables, and aiohttp for our asynchronous web requests. And finally, step 3, point our script to that RPC endpoint we just talked about. And just like that, our data catching net is fully woven. As for your setup, the project files are going to look exactly like this. We'll have collector.py, which is essentially the engine doing all the heavy lifting, then schema.json, which sets our strict data rules. And inside our output folder, we're going to get transaction_demo.csv and metrics summary.json. By the way, if you are exploring the courses in the Forge College learning community, you'll find that having a clean, reproducible project structure exactly like this makes sharing your code and collaborating with others incredibly easy. Now, check out this big number 10. We are only going to sample 10 blocks to start. Why? Well, because we absolutely do not want to accidentally DDoS a public endpoint. That would be bad. Starting out with a small, highly controlled loop of just 10 blocks keeps us completely out of trouble while we verify that our script actually works. It's basically the equivalent of testing that trail camera in your own backyard before hiking 3 days deep into the wilderness. Section 3, validating the valid benchmark schema, the VIP bouncer. So the crucial point here is that grabbing data is completely useless if the data itself is a mess. We need strict validation. I want you to think of the benchmark schema as the VIP list at an incredibly exclusive club, guarded by a very strict bouncer. If a piece of data walks up to the door and lacks the right ID, meaning it's missing a required field, it simply does not get in. No exceptions. This ensures our final analysis is based purely on flawless, complete data. Let's actually look at the VIP list itself. This acts as our defensive checkpoint. We need the timestamp _UTC, the slot number, the leader _pub key, the transaction signature, the observed _forward _TS, which, remember, is when the node reported forwarding activity, and finally, the observed _latency MS. Every single sample we collect must have these exact fields. To enforce this, we literally write an assertion into our code: reject missing fields. Now you might be wondering, why would fields be missing? Well, it happens all the time, because RPC block payload differences can vary wildly depending on the specific endpoint you happen to use. So our code has to aggressively assert that these fields exist before we even think about moving to the aggregation phase. No exceptions, lock it down. Section 4, aggregating the metrics.
making sense of the raw data.
Okay, our clean data is finally inside the club. Hooray. But now we have to summarize it so we can actually read the Gulf Stream efficiency signals. We've got three main analytical goals here, which we're going to tackle using Python's absolutely fantastic pandas library. First, we calculate the total sample count. Second, we find the median latency in milliseconds. This tells us how fast transactions are typically being forwarded on average. And third, we map the number of samples per slot to check our throughput across the entire run.
And this brilliantly illustrates what that third goal looks like. Mapping our samples across different slot windows gives us a really quick visual check. It confirms if our samples are evenly distributed based on our original strategy. Think about it. If one slice of this chart is massive and another is tiny, we might have a serious sampling bias, or maybe the network was just behaving very strangely during that specific window.
Section 5, Spotting Anomalies and Next Steps, Finding the Mutations.
All right, we are in the final phase of our investigation. We have our clean, aggregated data, and now we get to use simple statistical flags to surface dataset outliers, or what I like to call mutations, for manual review. Honestly, this is the exciting moment. This is exactly where we put our magnifying glass over the data and spot the weirdness in our otherwise predictable network behavior.
Take a look at what happens when we compare a stable network to an anomaly. On the left, we have our expected stable latency range. Smooth sailing, everything is fine. But on the right, we have a latency outlier, a sudden, massive spike flagged by our interquartile range math. This is exactly the kind of clue a data detective is looking for. We have to ask, why on earth did the latency suddenly triple in that specific second? Sample density builds our case even further. When we compare normal sample density against a notably high sample density in one specific slot, it tells a story. This kind of uneven distribution could totally point to a leader scheduling bias on the Solana network. Or it could simply be repeated missing forwarding timestamps coming from our specific RPC endpoint. But hey, before you run around declaring that the sky is falling, remember this golden rule. Interpret anomalies conservatively. Flag those suspicious slots for sure, but then cross-check them to avoid chasing transient noise. Seriously, you always want to cross-reference your findings with another endpoint before jumping to massive conclusions about a total network failure. Sometimes, a glitch is really just a glitch. So, I'll leave you with this somewhat provocative thought. What do these anomalies actually reveal about Gulfstream's true processing power? Think about it. Our clean data, our captured latencies, our carefully identified outliers. All of these are just pieces to a much larger puzzle. And in our next step, we'll be turning these raw CSV artifacts into a really compelling capstone report. And that officially wraps up our lab session for today. I highly, highly encourage you to continue your investigation. Go put your brand new detective skills to the test and try building this pipeline yourself. Be sure to visit forge.college to learn more about this subject, dive into our comprehensive courses, and explore a huge wealth of other Web3 related topics. Keep questioning the data, and I will see you in the next explainer.